Hello all. So today I'll be explaining the concept of dynamic programming. So I will basically explain this concept by using a problem. So if we go ahead to the problems, our problem statement basically is there is a person Ram who has to travel from one end of the island to the other end of the island, and he has he has certain constraints like he has limited left with him, so he can travel only up to 8 kilometers. So the goal of the problem is to uh, find a path which is less than 8 kilometers, and find a path to the destination which is less than 8 kilometers. So if we are able to successfully find such a path, we need to return yes. Otherwise, we need to return no. So if we see in the first problem, there is actually a path. There are actually multiple paths that lead to the destination, and hence the output is returned as yes. Whereas in the second example, there is not even a single path which is actually less than 8 kilometers, and hence the output that is returned is actually no. So first we will try to solve this problem using brute force approach, and then we will go to the dynamic approach. So in brute force approach we'll try all possible combinations from start to end. So at every possible cell the RAM can either move down or move towards right. So if we form a tree like structure, we will get all possible combinations, and from that we will choose the combination that gives the total kilometer which is less than 8. That is actually the path that we need for which will be the optimal path. So going forward to the problem using brute force approach, so we can see like in the first path, he will generally move right, down, right, and again down. So the total kilometers that he travels is 1 plus 3 plus 5 plus 1 plus 1, which is equal to 11 kilometers. And since it is actually greater than 8 kilometers, Ram ends up getting tired and he won't be reaching the destination. So this is not the path that we need, and we can discard it. And going ahead to the next possible path that he can take, it is first moving down, then moving right, and then moving again right, and finally moving down. So if we see this path, the total kilometers that he travels is 1 plus 1 plus 5 plus 1 plus 1. So the total kilometers is 9, which is again greater than 8. So this is not also one of the paths. Now moving to the next path. So if we can see, like now in here he can move down, he can move right, he can move down, and he can move right. So if we calculate the distance traveled using this path, it will again turn out to be greater than 8, which is not the required path, since the his fuel is limited to only 8 kilometers, and we need to find a path to the destination which is less than 8. So again, we'll go out and try another possible combination. So in this combination, he's moving down, down, right, right, and he's reaching the destination. And here also he turns out to be tired, because here also he travels 1 plus 1 plus 4 plus 2 plus 1, which is again greater than 9 kilometers. Now moving to the next possible path. So now he moves right, down, down, and right. So now the total kilometers that he travels is actually much greater than 8. It is 12 kilometers. 1 plus 3 plus 5 plus 2 plus 1. And so this path is also discarded. Now coming to the next possible path. So in this path we will move right, right, down, and down. So we will reach the destination with the total kilometers of 7, which is actually less than 8, and this is the required path. So when we solve the problem using the brute force approach, it will return this path as it travels to the as Ram is able to travel to the destination using this path in 7 kilometers, which is less than 8. So that's why he's happy, and as shown in the animation. Now, if we see why greedy approach is why we cannot use greedy approach to solve this problem is, so if I explain to you why greedy cannot be used, so see, in greedy, we will always move towards the path which has the least value. So if we start at the starting point, so between 3, he can either move down or he can move right. So between 3 and 1, we will choose 1. And again, he has moved to 1, and now again between 5 and 4, 4 is lower than 5, so you'll choose 4. And then again when he's at 4, he can either go again down or right, but down will reach to the out of cell, so he will return back, so he will move towards right. And similarly in 2 also, there is no path to move downward, so he'll move towards right. So by using a greedy solution, we will get the total kilometers traveled is 9, which is actually greater than 8. So using a greedy approach also will not give us the solution, and that's why greedy approach is not useful in this case.